Today, in our example video for 1.5, we're going to be going through a couple of problems from the homework, and we're going to be starting with, this one is number 7. So this is number 7 from the 1.5 homework. And this is asking us to take the derivative of this function that's the 4th root of x minus 4 over x. And at first glance, we might look at this and say, we didn't cover functions like this, but this is what I talked about right at the end of our concept video, is that the power rule is actually really flexible. The power rule still works for fraction exponents and negative exponents. So let's look at this function. Well, first of all, because I have the subtraction, I know I can focus on each of these pieces individually. So let's start by looking at this. This represents the 4th root of x. Well, because that's a root, I can rewrite this as x to the 1/4. Because I just have x, so it's not x to a power, it's just x, so that's why I have a 1 in the numerator for my fraction, for my exponent. And because it's the 4th root, it's 1/4, it's x to the 1/4. So that first term I can rewrite as x to the 1/4. What about my second term? 4 over x. Once again, you might look at this and say, we didn't cover stuff like this, but remember, if I just have an x, I can always put an exponent of a 1 next. I can attach an exponent of 1 to it. Well, now I have a power function in the denominator. And if you ever have a power function in the denominator, you can move it up to the numerator by giving it a negative exponent. Now, to be clear, that doesn't affect the 4. The 4 stays in the numerator, stays just as a coefficient. I'm not going to switch that to the denominator or anything. But now I can rewrite this as a negative exponent, as x to the negative 1. Why? Because that x was in the denominator. And now that we write it like that, now I can see how, yeah, both of those are just power functions. And so now, once again, I can just take the derivative of each of these pieces. So what's my derivative going to be? Well, for my first piece, I'm going to multiply by the exponent, keep the x, and then subtract, and then my new exponent is going to be 1 less than what it used to be. Well, what's 1/4 minus 1? I get negative 3/4. So I have 1/4 x to the negative 3/4. My sum and difference rule means I just keep that subtraction, and then I can focus on my next term. Well, my constant multiple rule tells me just keep the 4 there, and then focus on the derivative of x to the negative first. And the derivative of that is, right, I'm going to multiply by whatever the exponent is, and then do x to the, and then minus 1 from the exponent. Decrease the exponent by 1. Well, negative 1 minus 1 gives me a negative 2. Very nice. So now I can clean this up a little bit, and I get 1/4 x to the negative 3/4. And then since I'm minusing a number that's going to be into being negative, I can go ahead and change that to a positive. Because what's negative 4 times negative 1? Just a positive 4. So I get 4 times x to the negative 2. Now, I could keep going. Since I have negative exponents, I can move these to the denominator, but I don't have to. I can go ahead and just plug this in for my answer into Pearson, and it'll accept it. The next problem that we're going to go through from the 1.5 homework is number 14. So with this one, we have just kind of a more basic polynomial, as we can see. My function is just a more basic polynomial. But the question's kind of worded interesting because it's talking about tangent lines, which of course we talked about back in 1.4. So this is asking for what point on the curve of y equals 6x squared minus 9x is the slope of a tangent line equal to negative 57. Well, remind me what we talked about in 1.5, or I guess remind yourself. Remind yourself what we talked about in 1.4. How are derivatives related to tangent lines? Well, the derivative is the slope of the tangent line. So right there where it says slope of a tangent line, what is that talking about? That's just the derivative. So I want to know where the derivative is equal to negative 57. That's what this question is asking me. Where is the derivative of this function equal to negative 57? Well, how do I do that? Well, first I need to find the derivative. So what's my derivative of my function? Once again, since I have two things being subtracted, I can focus on each piece individually. So for that first piece, I'll keep the 6 and focus on x squared. What's the derivative of x squared? 2x. Now for the next piece, I have 9x. What's the derivative of 9x? Since it's a linear function, it's just whatever the slope is. In our case, 9. I'll go ahead and simplify this a little bit. So I get 12x minus 9. So there's my derivative. And what do I want to be true about my derivative? I want my derivative to equal negative 57. So what do? I set this equal to negative 57. Set it equal to negative 57 and solve. Okay, I'll add 9 to both sides. And I'm left with 12x equals negative 48. I can divide by 12. And I get x equals negative 4. And there we go. There's my x value for where the slope of the tangent line is negative 57, where the derivative is negative 57. So there's my x value. My x is equal to 4. Now you'll notice that the answer wants an ordered pair, so I do need to find what the y value is. How do I do that? I can come back up here to my function and plug in negative 4. So I can go y is equal to 6 times negative 4 squared minus 9 times negative 4. And I'm left with 6 times 16 plus 36. 9 times 4 is 36. And it's a positive now because there was 2 negatives that canceled. And I get 132. And so there's the y value. So there's my coordinate point. My x value is negative 4, and my y value is 132. And there's my answer. That's what I would plug in. Okay, if you have any other questions from the homework, please reach out. Hop onto the Zoom call for office hours or send me an email and I'd be happy to help you. But good luck.